In this video, we are going to talk about the laws of logarithms. So first, we're going to review what we already know about logarithms, and we've talked about our rules a little bit. So if I have a base of b, and it's equal to something, and that's equal to 1. So that means it's going to be b to some power is 1. Well, anything to a power, any power that gives you 1 is going to be 0. So b to the 0 power would give you 1. Now in this case, I have b to some power would equal b. Well, anytime you have a base raised to the same as the base, it's going to equal 1. So then, for example, if I had log base 3 of 3, that would also be 1. So anything times the base and what you're raising it to, it's going to be 1. Same idea here. When I have b and b, that means that my answer is just going to be my exponent. Or again, log base b and b, my answer is just going to be x because those equal 1. ln of 1 always equals 0, and ln of e always equals 1. ln of e equals 1, and so that means this would equal x. ln of e again equals 1, so this would equal x. Our exponent rules, remember when we're multiplying, what we're going to do is add our exponents. When we're dividing, we're going to end up subtracting our exponents. And when we have a power to a power, we're going to end up multiplying our exponents. So these same properties are going to actually apply to our log rules. So here I have log base a of a times b. So how we would expand this is I would have log base a of a plus log base a of b. So multiplication means I add those logs together, and I could also go back the other way. If I was adding, I would change it to multiplication. When I'm dividing, it's going to be subtraction. So log base a of a minus log base a of b. And when I have a power, what's actually going to happen is this exponent, the c, is going to come down in front. So it's going to be c times log base a of a. So anytime you have an exponent, it's going to come down in front and become a multiplier. So let's use some of these new properties to expand. So now we're going to try to make it bigger. These logarithms. So I can see that I have 25 times x to the third. So when I have times or multiplication, I'm going to change it to addition. So I'm going to have log base 5 of 25 plus log base 5 of x to the third. Now, it's nice to simplify this because log base 5 of 25, I can actually simplify this. So that means it'd be like 5 to what power is 25? So that would be 2. So this would simplify to 2 plus, and then what I'm also going to do is this exponent is going to come down in front. So I would have 2 plus 3 log base 5 of x. And so this is how this first one would simplify. In this next one, we're going to do a couple things. So first I have 3 times this top, and then I have it divided by 16. So I'm going to have addition for the top and subtraction for the denominator. So first I'm going to have log base 2 of 3 plus log base 2 of y plus 1 squared minus log base 2 of 16. So we can do a couple of things here. First, I have an exponent. So again, that exponent is going to come down in front. I also can simplify this log base 2 of 16 because that'd be the same as 2 to what power is 16. So I'm going to have log base 2 of 3. I can't simplify that because 2 to no power is going to give me 3, or not to a whole number, so we're just going to leave that one. Plus 2 times log base 2 of y plus 1, because I brought that exponent down in front, minus, will be 2 to the 4th power would be 16, so minus 4. All right, now we have natural log, but it's really the same thing. So I have ln of e to the 6th on top, minus, and then I have these are technically two things multiplied together. I could break this up as the cubed root of x and the cubed root of y. So minus the ln of the cubed root of x plus the ln of the cubed root of y. So remember that the cubed root of x would be the same as x to the 1/3 power. So what's going to happen is each of these ln's is going to get a 1/3 power in front because of this x to the cubed root of x. I'm also going to bring this 6 down in front. So I'm going to have 6 ln of e, and then I'm going to also distribute this negative in. So minus 1/3 ln of x minus 1/3 ln of y. Now, ln of e is equal to 1, so I really am just going to have 6 times 1 here. So my final answer is going to be 6 minus 1/3 ln of x minus 1/3 ln of y. All right, now we're going to go the other way. Now we are going to use our rules to simplify. So again, adding is multiplying. So I'm going to change this to log base 8 of 2 times 4, which would be log base 8 of 8, and log base 8 of 8 is 1. In B, I have a number in front, so this number in front is going to become the exponent on the 6. And same with this 1/2 in front, that's going to become the exponent on the 9. So I see I have minus and then a plus. So I'm going to have log base 12, 6 to the 3rd power. Minus means that this 4 is going to go in the bottom, but that plus means that the 9 to the 1/2 is going to end up on top. So that means I have log base 12 of, well, 6 to the 3rd power would be 36 times 6. So that's 216. So 216 times, well, 9 to the 1/2 power is the same as the square root of 9, so 3 all over 4. Ooh, so log base 12 of, well, 216 times 3. Actually, let's do 4 divided by 216, and then we can multiply it by 3. So 54, and then 54 times 3 would be 162. So this comes out to log base 12 of 162. And that won't simplify because 12 to the 1st power is 12, 12 to the 2nd power is 144. So nothing is going to directly go into 162. All right, so I got this number in front. So again, that means I'm going to give the power to this whole guy and this whole guy. So the first thing I'm going to have is, this is basically become log of 2x squared minus log of y squared. So I got minus, minus, minus. So I have this first guy is going to be on top. So this is going to be on top, and then all the rest of these are going to be on the bottom. So log base, just log base, just common log. So we're going to have 4x squared on top, y squared times 3 times, and then I got this 2, so that's going to become the exponent on the 5 times 5 squared. So common log 4x squared over, well, 25 times 3, so 75y on the bottom, or y squared. All right, in this first example, it says show that 2 minus 2 log of 20 is equal to negative log of 4. So this is common log, so I know this is something with common log that got simplified to 2. So basically, something to the 2nd power equals something. Well, I know it needs to be common log, so I know it needs to be base 10. So that means it must have been log base 10 or common log of 100 to give me a value of 2. So I'm going to swap out that 2 with a log of 100, And then this 2 in front is going to become the power on that 20. So minus log base, common log of 20 to the second power. So when you're subtracting, again, I'm going to end up log of 100 over, well, 20 squared is 400. So that would be log of 1/4. Well, 1/4 is the same as 4 to the negative 1 power. But I know that if I have an exponent, I can bring that exponent down in front. So it'd be negative 1 log of 4, which would be the same as negative log of 4, which is what I want it to equal. All right, let's do some evaluating using our rules. So again, my base is 5, so 5 to some power is going to equal the cubed root of 25. 5 to some power, well, 25 is the same as 5 squared, so this would end up being 5 to the 2/3, because again, the cubed root of x would be the same as x to the 1/3. So that means in this case, my answer would be 2/3. 2 to some power is going to equal 1/16 to the pi power. Well, 1/16 would be the same as 2 to the negative 4. So I'm going to end up with 2 to the negative 4 pi. So that means x is equal to negative 4 pi. All right, in 5 and 6, I have subtraction. So I know that I really have log base 49. Oh, well, I can't subtract these because they don't have the same base. So we're not going to actually use our subtraction rule. I'm just going to change each of these into log form. So 49 would equal something, some power equals 7, and 8 to some power would equal 64. So this would be 1/2 power minus second power, so negative 3/2 would be my answer here. Or if you said negative 1.5, that would work too. All right, anytime I have the same base with the same value, the answer is just going to be the exponents. The answer to this one is just b. You could also think about it as that you're bringing that exponent down in front, so it'd be b times log b of b. Log b of b is 1, so b times 1 is b. Now I have subtraction with a common base, so I can say this is log base 9 of 25 over 75, which would be log base 9 of 1/3. So that means I want to think about it as 9 to whatever power is 1/3. So it's going to have to be negative. Well, so let's just switch this. So this is 3 to the negative 2x, or sorry, not negative 2x. This is 3 to the 2x is the same as 9x, and this would be 3 to the negative 1. So that means 2x would equal negative 1, which means x would equal negative 1/2. All right, so they want us to simplify this knowing that ln of 2 is a and ln of 3 is b. So how can I break down 27? Well, I can break down 27 into the natural log of 3 to the 3rd power. I'm going to bring that 3rd power in front, so I'm going to have 3 ln 3. Well, if ln of 3 is the same as b, this would be the same as 3b. In b, I'm going to change this to be ln of 6 to the 1/5 power. That 1/5 power is going to come down in front. Now I have 6, and I really need it to be 2 or 3. So I'm going to break this down into ln of 2 times 3, meaning it would be 1/5 ln 2 plus ln 3, because when I have multiplication, it becomes addition. So this would be the same as 1/5 a plus b, because ln of 2 was a and ln of 3 was b. In c, I'm going to change this to ln of 2/3 to the 1/4 power. So again, I'm bringing that 1/4 power down in front. And ln, if it's 2 over 3, that's subtraction. So ln of 2 minus ln of 3. Well, that's a and that's b, so it'd be 1/4 a minus b. In these last two problems, we are going to solve without a calculator, but they're going to give me an approximation to use. So if I have log base a of 21, I could rewrite that as log base a of 3 times 7, and I get that hint from the fact that they're telling me log base 3 and log base 7. So multiplication means that I'd have log base log base A of 3 and log base A of 7. And I'm going to add those. So I'm going to have 0.5 plus 0.8. And that would equal 1.3. In this case, I have log base A of 9 minus log base A of 7, because when you divide, you subtract. I'm going to change 9 to be 3 squared. Bring that exponent down in front. So I'm going to have 2 times 0.5 minus 0.8. So that's 1 minus 0.8, which would be 0.2.